Hello, my name is Christian Frank, and this is the video for ECE376 Embedded Systems, homework set number 9, Timer Interrupts. For this homework set, we are required to write a program that uses multiple timer interrupts. I personally used all 4 timer interrupts that are on this processor: the timer 0, timer 1, timer 2, and timer 3 interrupts. Now to go into the logistics of how my program operates. So for the software side of things, my program takes inputs on all 8 buttons for port B here. Based on the input that it receives, it calculates 3 output signals and outputs them on port C pins 0, 1, and 2, where these resistors are coming out of. For the hardware setup, you have 3 270 ohm resistors coming out from each of the output ports and coming over here, which connects into the speaker, and then the other side of the speaker is grounded. So how the functionality of the hardware works is that 3 signals will be output from port C and come into the speaker. Now, the program is built where it outputs 3 signals on those ports, and each of the signals that are output are at a different frequency. So therefore, the hardware takes each of those signals and plays them so all 3 signals combine and are played on the speaker. So therefore, the speaker will be playing 3 different sounds at the same time. We have the 270 ohm resistor here to protect the processor because the speaker would ask for more than 20 milliamps, but the PIC cannot support more than 20 milliamps, so the 270 ohm resistors are there so that the speaker doesn't try and draw too much current from the PIC. And also, 270 ohm resistors are also there to help protect each of the signals so that each signal remains unique when they combine and are output on the speaker. Now back to the software side, my program is named Piano.C for 2 reasons. The first reason is the signals that are output are actually going to be chords that you can play on the piano. And the second reason is how the input buttons are set up. So the first 7 buttons for the input from 0 to 6 here, your first 7 buttons correspond with actual keys on the piano, and they're called the key buttons. So using these buttons, you can select what key you want to play, or effectively you can select the key signature for the chord. Now over here on the piano, you have, of course, your white keys and black keys, but for any specific octave here, for a specific octave, you have exactly 7 white keys, C, D, E, F, G, A, B, 7 white keys, and 5 black keys. So each of the white keys maps directly to each of the buttons. So you have C, D, E, F, G, A, B. To play the black keys, if you wanted to play like a D flat here, you simply find the 2 keys that are next to it, so the C and the D. So to play the black keys, you simply push down the 2 buttons that the black key would be in between. So on here, the black key is between your C and your D. So you'd be pushing down both RB0 and RB1 at the same time. Pretty simple. So therefore, in effect, the first 7 buttons basically are very much like an actual piano. So to select your key, you simply play it kind of like how you play a piano. Now here's the neat trick. The last button, RB7, is a special button that's reserved. Using these keys, you press down whatever key signature you want, and the program will output the signals, the appropriate frequencies, for a major chord, the major 1 chord for that key signature. However, if you, while you are pressing down the buttons for the key signature that you are wanting, if you also press down 7 along with the key buttons, pressing down 7 at the same time will change it from a major 1 chord into a minor 1 chord. So therefore, it now will be outputting slightly different frequencies. So not only can you now play all 12 major 1 chords for each of the key signatures, but you can also play all 12 minor 1 chords. So therefore, the Piano.C plays all possible major and minor chords for a given octave. And the octave that I chose is the octave with middle C, so I chose the 4th octave, C4 up to B4. So it plays all possible major and minor chords for your 4th octave. So, now to actually give you a little example of how it works. So now, if I press RB0, it'll play the major 1 chord. Very simple. If you come over to the piano, you have your major 1 chord as well. Then you can play C sharp by pressing RB0 and RB1 at the same time. So therefore, you just simply play every key. Any combination that you want. The program takes into account that between your E and your F, there is no black key on the piano. So the program takes that into account, and it does not set a specific frequency for pushing down RB2 and RB3 at the same time. In addition, if any invalid combination is pressed, like trying to push down a C and a G, obviously that doesn't give you an appropriate key signature, because between C and G there's no one black key between a C and a G, only between C and D. So if you have more than a space of 2, it's also deemed as an inappropriate combination. And finally, pressing 3 buttons is an inappropriate combination, and just pressing RB0 without pressing any of these buttons is an inappropriate combination. So how I wrote my program is anytime an inappropriate combination of buttons is pressed, it just maintains the same key. So if I choose E, for example, but then I hit RB7, it'll just keep playing E because it's not a valid combination. Same goes for in between 2 and 3. If I start by pressing RB3 for F, and then I try and press RB3 or RB2 for the E, there's no black key between the two, so it'll just keep playing the F. So the program is set up with a built-in fail-safe function where anytime they press an inappropriate combination, so like in between these two where there is no black key, or multiple buttons that don't represent a white key or black key, or just RB7 without pressing any key buttons, then it just keeps whatever previous key signature you had and keeps it at that. Now, one slight note is it doesn't really work with keeping it when you have 2 buttons to try and do a black, and that's because as you release the 2 notes, it automatically, when you release it, you happen to release one button slightly faster than the other. It's too fast for humans to notice, but not fast enough for the processor. So the processor will automatically select one of the two. So if you press both of these for like the D flat, it won't play a D flat. In this case, it's actually playing the C. So that means I release the D slightly before I release the C. So then for the processor, it recognized the C as being the last valid key. So that's basically how it works. Now I'll press RB7 so you can hear the minor conversion, as I haven't done that yet. So you have C, C major, and then if I push down RB7, it all of a sudden switches to playing the minor. So you can hear just the slight difference from C major to C minor. And if you're not familiar with that on a piano, so I can play the C minor and lock in that chord now, C minor, and you can hear that it is indeed playing minor. And I can do the F minor. So you can play any major or minor keys depending on how you want it. So there you go. Piano.C. Literally a piano program where your key buttons are literally like a piano interface. You can push these buttons to set the key signature for the chord. While holding down the buttons, it'll output a major signal and play your major 1 chord on the speaker. And then if you press down RB7 at the same time as your key buttons, then it'll change it so that it is actually outputting a minor signal, and it will play the minor 1 chord. So the program part of itself has 4 timer interrupts. The timer 2 interrupt is used to see what the input button is set to. So every 1 millisecond, it reads the input ports to see what they are set to. And based on that, it calculates how long the other timer interrupts need to be set to. The timer 0 interrupt controls the signal out of port pin 0, timer 1, the signal on pin 1, and timer 3, the signal on pin 2. So based on that, what your input signal is, it sets the times that the timer 0, 1, and 3 interrupts run. And then those interrupts now run for that period of time, and each of those interrupts just inverse the port on port C, inverse the bit. So if it's a 0, it becomes a 1. If it's a 1, it becomes a 0. So each time you go through the timer interrupt, it is creating half the wave that is being output. So therefore, it outputs your square wave based on that. And the program is already pre-programmed for all the corresponding frequencies that have to be output. So it knows what clocks each of the timer interrupts need to run for in order to play any specific note. And based on the buttons that the user inputs, it knows what notes it needs to play, sets the timers to the appropriate number of clocks, and then outputs your signal on port C, which then comes through the hardware setup to your speaker and plays as a chord that you can hear. So, pretty simple setup. That's your Piano.C. One thing I should note, as I had mentioned, if you press an invalid operation without starting, it will play the default chord. So then, it'll play the last key signature that was set. If you press an inappropriate, invalid solution of keys, it'll play whatever the last one was that you asked it to play. So then, what does it play at startup? So when the program first starts up, I set the default chord to be the C1 major chord. So the default key signature is just your C4. So that's the key that it will play on startup, which you can test simply here. So I'll restart the program here. and it'll start up. And if I press RB7, like an inappropriate, invalid solution of buttons here, it plays C. Pressing the C gives you the same. So it's automatically set up to handle a default scenario. It plays the C, and then after that, it plays whatever value you select once an appropriate one has been selected. So there you have it, the Piano.C program, taking input from the user, using the timer 2 interrupts to take the input from the user and to output 3 different signals, and then each of those signals combine to your speaker and plays a chord. Thank you very much for watching.